A few years ago, my dog Bailey burnt down her house, so I built her this heated doghouse suitable for even the coldest winters. Fast forward to now, and it's been one of the hottest summers on record.
God, it's hot.
So in this video, I'm building a brand new doghouse that uses the power of the Earth's built-in air conditioning. An off-grid geothermal house that'll keep my dog cool on even the warmest summer days. Like most of my builds, this story begins with a trip to the lumber store to pick up a lot of the wood I'm going to need to start this doghouse. This doghouse is going to look like it's mostly built out of cedar, but the first step of this is my deck framing, and for that I'm actually going to be using some pressure treated 2x4s. So I measured out my pieces and marked my cut lines, and then I'll be cutting these to length with my miter saw. With my main pieces cut and laid out, I'm going to fasten these together with a couple of 3-inch deck screws into each stud. I also added some block in between each of the joists. This should give the floor a lot more overall strength, and I measured some of these out to line up with the exterior walls so that I have some framing to fasten the walls down to, as well as an insulation stopper. With the main framing complete, I'm going to be using this 6-inch cedar deck board to cap around the outside. So I set my miter saw to a 45-degree bevel and cut my pieces to length. And then these are going to go around the outside edge and basically case in that framing. I also have this scrap piece of deck board that I can set on top for a gauge, so that I can raise up this casing to be perfectly flush with the deck boards that'll be put on here next. While I was adjusting these pieces, I just tacked them into place using a brad nailer. And then once I confirmed everything was going to work out, I came back with some 2-inch deck screws and screwed in through the back side to hold these boards in place permanently and not show any exposed screw heads. And now I can start installing my cedar deck boards. Rather than face screwing these, I want to keep this looking fairly clean, so I'm using this camo deck screw jig. This uses special screws that screw in through the side of the board, and then by the time the next board is installed, you can't even really see the fasteners. This is a really slick way to put down decking. It also automatically does the spacing for you, and comes out with a lot cleaner look in the end rather than face screwing these. And that's a nice looking deck onto the walls. So for my walls, I'll be using some 2x3 standard lumber. And screwing these together the exact same way as the deck with a couple of 3-inch screws. So I built an angle into some of these walls. On a couple of them the top plate was angled, and on the rest of them they angled up from one side to the other. This is to match the slope of my roof, and you'll see why I wanted to do this in a few steps later on in this video. So after I had my walls set in place and all fastened together, this is as far as I can go with this standard wall design. And for the next one, I need to get a little more creative. So for this one, I'm making an outer frame of the wall with some cedar 4x4. And then I have a big piece of this plexiglass I got cheap on Marketplace. The glass is a 1/4 inch thick, so I'm gonna have to cut some sort of 1/4 inch slot into each of these 4x4s so that I can slide this plexiglass into place as I'm assembling the frame and basically have a big bay window in this doghouse. So there'd be lots of ways to do this, but I figured the easiest way for me was to just use a track saw with a depth stop and then line up the track with my cut lines and make a few cuts to widen that out until I'm about a 1/4 inch thick. This is basically a workaround of a dado blade and a table saw, and it worked pretty quickly and easily. This should accept the plexiglass just fine. With all my 4x4s cut, I can cut my plexiglass to size, and I just used the track saw for this and took it slow, making sure not to crack the glass. So then I can start assembling the frame. Starting at the bottom, I'd glue the end of my joint, and then clamp it in place while I pre-drill a hole and then set in a couple of 5-inch screws. Before I slide the glass into this, I'm going to drill some weep holes through this bottom slot. And then using a straight flute router bit, I'd route out this channel on the bottom of the frame out to the front side. That's going to allow water to escape from the window frame. These are going to be weep holes, so basically once it rains onto this window and all that drips down into the bottom slot, that water can escape through these drilled holes and out through the front edge of the frame to prevent any water damage and rot. Lastly, I can slide that plexiglass panel into place and close up the frame with the final piece. So now I can set this final wall/window into its place on the deck and give it a few screws to secure it. And then I added in one more 4x4 post and this 2x8 header over the door to close in the final pieces of the wall structure. Before I add the exterior wall paneling, I'm going to install this house wrap over top of the studs as an extra layer of water protection, and this just gets stapled into place and then trim off the excess. Now for the actual wall panels, I'm going to be using this LP Smart siding. This is an OSB sheet that's stamped and primed on the one side to look like this wood paneling. And this is really easy to install. I just cut it to size with my track saw and then nailed it onto the studs every 6 inches or so with a 15 gauge or brad nailer. For the rest of the siding, I have some of this clear cedar 6-inch tongue and groove left over from various other projects. So I'm going to be using this on the front wall of the doghouse. This stuff clicks together for a pretty sleek, seamless look, and since it's cedar, it should last outside for many years to come. So I ripped some pieces to size with the table saw, and to length with the miter saw. If you nail these properly along the tongue, the next piece should always cover up the nails, which gives this a really clean, professional look. So there is inevitably going to be a few exposed nails near the edges, so I'm filling that in with some cedar wood filler. And after an hour or so, I can come back and finish sand this. For the nails along the siding panels, I found some old caulk and worked it in all these holes. To paint the siding panels, I'm using this leftover paint from my sauna build. I'm trying to use as many leftover materials as I have here because every build generates quite a bit of waste. And with a small project like this, I can use up a lot of those leftovers. Then I'm going to be using this outdoor black paint to paint the window and door area, and hopefully give this a pretty sharp, modern look. So now this structure is obviously missing one crucial component. I'll be building the roof for this all in one piece so that I can set it on hinges and basically make a pop-top roof, which makes the whole inside accessible. So the slope of my roof is 6 degrees, so I cut some 2x4s with this 6-degree angle. And then for my end plates, I ripped a 6-degree angle into the one side. So now I can just screw together some more framing, using some more of these 3-inch screws, and some more blocking for support. Then I have this cedar tongue and groove paneling from Home Depot. This is similar to the stuff I was using before, but it's not clear, and this stuff's quite a bit thinner at only about 7/16 of an inch, which will make this roof quite a bit lighter, and since the roof is going to be liftable, that's fairly vital. This installs the exact same way, nailing the tongue and the following piece covering up those nails. So for my lighting, I'm going to be using these 12-volt deck lights. These are some really low wattage lights that aren't going to be too bright for this small space. So basically these just have a 12-volt power supply that plugs into the wall, and then you can add on as many lights as you need by simply connecting the wires. They're also a 12-volt, which means I can likely bypass this power supply and connect it straight to the house battery later on. So to install these, I just marked out my light spacing and then drilled the proper size hole with a hole saw, and then these just slide right into place. With all the lights installed, I need to flip over my roof so that I can connect all the wiring in on the backside. Like I said before, these are pretty easy to install. We're really just connecting these wires and finding a somewhat clever route to route these wires around as short as possible. And once I have it all connected, I'm going to hook this up to a power supply just to make sure everything's working before I move on. So back at the doghouse structure, I need to install these hinges that are going to pivot my roof for me. So I'm going to use a straight flute bit in my router and make a few passes to countersink this hinge down. so that there isn't too much of an air gap between the house frame and the roof. Now we can lift the roof into place up onto this temporary support I made until I can fasten it securely. And that seems to work pretty good. It's fairly heavy, but I think I'll add some gas struts to this later on to take most of the load. This is going to make this doghouse a lot easier to clean and access. The last one I made only had the little front door, and we ended up having some pet bunnies in there, and it got pretty much impossible to clean the house. And if you don't know it, bunnies like half their body weight a day. So it got pretty gross, but also inspired this lifting roof idea. So until I have the struts on here, I added these support pieces so that this roof doesn't crash down and cause a minor injury like crushing my skull. This doghouse is going to be fully off-grid, so my power supply for this is this 20 amp hour 12 volt lithium battery that'll be housed inside this little closet within the doghouse. So I need to run some wires through the wall here, so first off I'm running some 10 gauge solar MC4 cables through the studs and finally out the wall, where it'll connect into these other wires I ran through the roof and will ultimately connect into a solar panel. So then I've got all these lights that are in the ceiling. Obviously this cable won't reach all the way to this power room, so with an extra light I snipped off one of the connectors, and then I'm going to solder this onto some extra wire so I can run that through the wall, all the way from the lights to the battery. One more thing I need to add before I start insulating is this hookup plug. This installs into the exterior wall, and then you can just plug an extension cord into this, and that transfers power into these two interior outlets. I'm going to be hooking a battery charger into one of these outlets so that if the battery dies, all you need to do is plug an extension cord into the building and it'll automatically start charging. So now inside the utility closet I have my battery, the solar cables coming in through the wall, the 12 volt lighting wire through the wall, and these AC outlets. I'll hook all this together later, but for now I'm going to go on with insulating the walls. For the insulation I'm going to be using these rigid foam panels, and I'd start off with a bead of expanding foam around my space perimeter, and then set my panel into place, and the expanding foam should expand around this to seal in any air gaps and adhere to place. On the ceiling I have 2x4 framing, so I'm using a panel of 1 inch and then another panel of 2 inch insulation. And the walls are only 2x3 framing, so I just use one 2-inch panel. Way earlier in this build, I had also insulated the floor underneath where the doghouse was going to sit. And that's the insulation done. My walls have an R value of 10, and the ceiling and floor have a 15. For my interior wall paneling, I'm using the same siding that I used on the exterior. And now I can start hooking up my electronics. So starting off with this solar charge controller, the wires connect into the corresponding terminals using these screw lugs. These wires run through the wall from the solar panel and connect into the charge controller's input, And then these output wires connect directly onto the battery lugs. These aren't the only wires being connected to the battery though. I also have the ones from the 12 volt lighting and the wire coming from the AC battery charger that need connected in here as well. So using these ring terminals, we can actually just put all three of these together and put the bolt through them and connect that securely to the battery terminal. So a map of what's going on here, the wires come from the solar panel through the wall into the charge controller, and the charge controller connects to the battery. Using an extension cord, I can hook the unit up to power, which is hooked into this 12 volt battery charger, and these wires connect onto the battery terminals for an alternative way to charge the battery. Lastly, the wires coming through the walls for the 12 volt ceiling lighting connects into one of these remote receivers, and then into the battery lugs. Using that receiver, I can control the lighting remotely. And that's this simple off-grid power system done. I just need to plug in a solar panel to charge it. Next, I need to finish all the exposed cedar on the deck and the walls and the ceiling. There's many options to do this. I just picked something I had around, which is this Rubio Duro Grit in a color that I liked. This stuff's fairly expensive, but any normal decking stain would do. One nice thing about this finish though is it's not gonna chip off like a cheap decking stain. This is an oil, so really the wood's just gonna dry out after a few years, and all you have to do is apply another coat, no sanding or anything. With that finished up, I'm going to work on adding some gas struts to the roof to make lifting that a lot easier and less dangerous. These are some 36-inch struts with a force of 150 pounds each. So I'm bolting this into place using some 1/4-inch lag bolts, and you definitely need to find the studs behind the paneling here. I'm really just tinkering around with this. I don't exactly know how to use these. I've never used them before, so I'm just kind of guessing on what feels right, and we'll see how it works out.
Well, it works, but too well. God. Oh yeah. Didn't quite have her in the right spot.
So it took a few times of putting this on and tearing it off before I finally got this set up right, and I had to keep moving this around because it would literally shear these bolts right off when it broke. But after 3 or 4 attempts, I finally got it working. I was planning to put on 2 of these, but it seems like one is plenty strong for now. So we're getting into the last few steps of this build now. Onto the roof, first off I have to put some plywood down, and I just used some 3/8 inch plywood I had left over from another job. And screwed it in with some 2-inch screws. So for this roof, I'm going to be using some metal standing seam roofing. So under that, I'm first going to have to put some of this ice and water barrier. This is a waterproof stick-down membrane that should ensure no leaks. This stuff's pretty expensive and honestly probably not super necessary for a doghouse, but I have this left over from another project I'm working on currently, so might as well use it. And now I'm ready to start the roof trim. Once again, almost all of this is left over from my tiny house and sauna builds a couple years ago, and it's just been sitting around my shop cluttering it up, so a small project like this is a great way to get rid of old scrap material. Starting off with the drip edge, I lifted up the waterproof membrane and slid this underneath and screwed it in with some pancake screws. And next goes this F-trim. This lines up with the bottom of the drip edge, and then I marked my top cut lines, and then I'll be cutting that out with some aviation shears. You're going to need a good pair of right and left hand snips for this to get you into the tight spaces you need to. And I just cut this out the best I could, remembering that water is always flowing down, so try to keep that in mind when you're bending and cutting. The top edge gets another piece of this F-trim, and then goes the fascia. So the fascia is just this L piece of steel, and I cut this up using some aviation snips as well. And then this slides over top of my fascia boards up underneath the roof trim to basically cap in the rest of the roof. I just secured this in place using a few aluminum trim nails, and that's the roof trim done. Now I'm on to the standing seam panels. Before I install one of these, I need to trim back this edge and cap the rib. As well as use this brake to bend over my bottom lip. These then install onto the roof one after another. This is a really waterproof system because the next sheet always covers up the screws of the previous, and that bottom lip caps right over top of the drip edge. The slope of this roof is only 6 degrees, so this is probably the most waterproof roofing system we could put on here. It's also really lightweight, about the quarter of the weight of asphalt. So that's going to make it a lot easier to lift up the whole roof on the hinges like I showed earlier. A little bit of thermoplastic caulking to seal up around any of the wires and the trim edges. Nothing like getting your hands messy with some black caulk. And that's a finished, way overkill roof for a doghouse. So pretty much my last major step here is adding a solar panel to charge my battery. So I picked up this 100-watt solar panel cheap on Amazon, and I'll be mounting this directly on top of the roof using these Z brackets. I'd add some MC4 connectors on the end of my cables that were feeding through the roof, and then this just plugs right in. And the rest of the electrical is already hooked up, so once this is moved outside, that'll be charging the battery. I used some more caulking to seal up underneath the brackets before I screwed this down into place. And that's a finished roof and basically a finished doghouse after a couple finishing touches. First off, I want to seal the door, and obviously a dog doesn't know how to work a doorknob, so I'm going to be using these vinyl flaps to make a flap door system that's common in like a hockey arena or a walk-in freezer. Coming up shortly in this video, I'm going to be going through a lot of work to make a geothermal cooling system, and without a door seal, any benefit that would have would just go straight out the door, literally. So that's a pretty simple flap door system that should allow my dog to go in and out easily, and at least be somewhat insulated. Lastly, there's a bit of an air gap between the roof and the top of the walls, so I have some of this foam weather stripping, and I'm just stripping that along the top edge of the walls to seal out that draft. And that's it for the construction portion of this build. I'm not sure how the next steps of this are going to turn out, but I can say one thing for certain, it's a pretty dang nice doghouse. So now it's time to get to this geothermal cooling idea that I have. First off, I've built up this simple template of the doghouse to mark out its position. I'm using this to visualize where the doghouse is gonna go and to paint out the lines where any trenches are gonna be dug. And then I have a bunch of lengths of this 3-inch ABS pipe. I'm just dry fitting these together, making a rough idea of where the system is gonna run. I'm basically building a big underground loop that takes air from the doghouse and pumps it underground, hopefully cooling it down as it runs through the piping before returning it to the doghouse. I have about a 50-foot loop of pipe here that I want to sink in the ground 3 or 4 feet, and we'll see if that's enough to keep this doghouse cooler than outside. I really have no idea if this is going to work or not. This is more of a proof of concept for future builds to see if this is a viable cooling and heating option or not. So anyway, let's get digging. I rented this trencher from Home Depot for 4 hours. I'm going to use this to trench down into the ground along all of my cut lines. So I was trying to get this line as deep as I could since most of the research suggested this at 4 to 5 feet. This is a 36-inch trencher and I managed to get the whole trench down to right about 34-35 inches. If this was a bigger project, I'd put some more firepower into this, but again, this is just a doghouse and I just want to get an idea of if this is an effective passive cooling system or not. If this shows any promise at all, then I'd consider using the idea for a human dwelling like a tiny house. And obviously take the time and money to build everything to exact spec then. So anyway, my 50-foot loop is now ready to be lowered down into the ground. After that, I added on my intake and exhaust pipes, and this is ready to backfill. The research I did also suggested much longer runs, like 300 or 400 feet, so we'll see how this 50-foot loop does in a small structure. So now the doghouse is about ready to move out to its final home. But I first have to cut a hole in the floor of this utility closet to allow those in and out pipes coming out of the ground to feed into this closet. And now let's take this thing home. So this was a little tricky to get in the exact right position. We had to back it out and bring it back in quite a few times because we only have about an inch to play with on each side of the pipes in that hole I just cut. But eventually we sat it down in the right place and now it just needs to be hooked up. So to connect this system, I'm first using one of these ABS elbows. And then I 3D printed this ABS flange that I built to accept this blower fan. There's going to be one of these pointed inwards blowing into the intake pipe and pointed outwards for the exhaust pipe. These fans are 12 volt and only use about 2 watts of power each. So if this does offer a beneficial cooling effect, this is a really low cost and low energy intensive way to cool a space. So I used a hole saw to cut through that closet wall, and then slid my flange directly into that elbow. Then I can install my fan in the right direction and screw that into place. I'd make this look a little more pretty if this was going to be a permanent setup, but for a proof of concept, this is going to work just fine. These fans are rated to move 50 cubic feet of air a minute, which would be enough to fully exchange the air in the doghouse like 3 or 4 times a minute. Obviously, there's going to be some resistance from blowing through the pipe, so I'd expect that to be half or even a quarter, but either way, we're getting a good air exchange rate here. So these fans can just connect directly onto the battery lugs, and let's turn them on for the first time. So basically the idea here is the hot air in the doghouse will rise and get sucked in this intake fan, which then travels through the pipes, hopefully cooling it down over its journey, before it returns to the doghouse through this exhaust. That's the theory anyway, we'll see if it works. So right off the bat I took some temperature readings and my intake air is going in at about 34 or 35 degrees, similar to the outside temperature. What's interesting though is that the exhaust is only reading about 28 degrees. So far this is working. I put a temperature sensor inside and outside the doghouse, so we're going to close this up for a while and see what happens. The top temperature is the sensor inside the doghouse and the bottom outside. We're starting off at about 12:30 with a 4-degree temperature spread, so let's let this cook for a while. After about 2 hours, the temperature spread was down to even, and after 3 hours, the inside was actually about a degree or 2 cooler than the outside. The next day, the inside was sitting around 4 degrees cooler than the outside, and a pretty similar story the day after that. So does it work? Kind of. It's not cooling the air that much below outside, but there's also a huge window in this doghouse that would be enabling a pretty big greenhouse effect. Naturally, inside was sitting 4 or 5 degrees warmer than outside, but with the geothermal cooling, we're actually sitting about 4 or 5 degrees cooler than the outside. So does it work? Yeah. Is it practical and was it worth all the effort and destruction? Absolutely not. But that's why I do things on this channel so that you don't have to. Either way, that's a pretty nice doghouse, so let's show Bailey her new home. Thanks for watching my video. If you haven't already, hit the subscribe button and leave me a comment of ways you think I can improve this design. As always, plans for this build are available for free on my website, and you can follow me on my Instagram for some behind the scenes. Till next time, thanks for watching.